So the next topic is your memory management unit. The main work of your memory management unit is to translate your virtual address into physical address. Always the address space is divided into two. One is your logical address, one is your physical address. By definition, logical address means the address that is generated by your CPU is called as your logical address. The other name for your logical address is your virtual address. So it is called as either logical address or your virtual address. The second thing is your physical address. Physical address is the address seen by your memory unit. That is, your memory unit can only understand your physical address and not your virtual address. So for that one reason, you have this memory management unit. So the CPU will be generating your logical address. Followed by that, this memory management unit will convert this logical address into your physical address. So there is one more concept called as dynamic routine, dynamic relocation, or as your dynamic loading. So in dynamic relocation, what will happen is that particular routine or that particular process is not loaded unless until it's called for. So when a process or a routine is called, then only that process will be loaded into your main memory. So why we use this concept is for one thing is for the better memory space utilization, and the unused or uncalled routine or the process will never be loaded. So this helps to save our memory space. This particular dynamic relocation do not require any support from your OS system. This can run on your run on its own. There is another one concept called as dynamic linking. So in the linking, we have two types of linking. One is your static linking and another thing is your dynamic linking. So what will happen is, in case of static linking, the system libraries or the program code, whatever you are using, that everything will be combined by your loader and converted into a binary program image. So in general, static means it remains the same, and your dynamic means it will keeps on changing. So your system libraries are never going to change. The system libraries or your predefined set of system libraries or your predefined set of things, and that is not going to change. So what the system will do is, it will combine everything together in by the load. So the loader will the next concept is your dynamic linking. So the linking is basically of two types. One is your static linking and another thing is your dynamic linking. Static means it will always remains the same, and dynamic means it will keeps on changing. So in terms of static linking, the system libraries and whatever the program code you have will be combined by the loader, and it will be given in the form of a binary program image. That is, this image will remains the same throughout the process, and this kind of linking is called as static linking, whereas your dynamic linking keeps on changing. So your dynamically linked library, that is the system library that are linked to the user program, when the program will run, and the linking will be postponed to your runtime. So in case of static linking, there will be a binary program image and that remains the same, and in terms of dynamic linking, the linking will be postponed until your execution time. So in the dynamic linking, we have another one small concept called as stub. Stub is nothing but your small piece of code that can replace itself with your address routine. So this stub basically indicates how to locate the appropriate memory resident library. So this stub will help majorly in your dynamic linking process. Whereas in dynamic loading, the concept we read earlier, that does not require any help from the OS to run. But in case of dynamic linking, this will require help from the OS to run. So our next topic is swapping. Swapping is nothing but the exchange of your process between your main memory and your secondary memory. So what will happen is, Swapping is a mechanism in which a process can be swapped temporarily out of your main memory to your secondary memory. So, the keyword here is temporarily. So, only for a certain amount of time, a particular process can be swapped out of your main memory into your secondary memory. So, once the operation is over, it can be swapped back to your main memory. So, that is the entire concept behind your swapping. Let us explain using this diagram. So this is your main memory and this is your secondary memory. So what will happen is, say for example there is a process here and that particular process is in a waiting state. So whenever something is in waiting state, you can move that process to your secondary memory and make some space in your main memory for some other process to run at that time. So in this case, the process P1 is swapped out to your secondary memory and your process P2 is swapped into your main memory. So what happens is P1 is swapped out and your process P2 is swapped in. And once the P2 completes its process, once the P2's process is completed, P2 can be moved back to your secondary memory and your P1 can be moved back to your main memory. So back and forth movement will happen. So this back and forth movement between your main memory and your secondary memory is called as swapping. So one important advantage of swapping is swapping helps us to improve the utilization of main memory. That is, when a process is swapped out, there will be an empty space. So using that empty space, we can process whichever is in the ready queue. So there is an ready queue consisting of all processes that are about to enter the main memory. So from the ready queue, whatever process that are waiting to be executed can be moved to the main memory. So this will improve the utilization of your main memory properly. The one very important thing we need to keep in mind is about the context switch timing. So the context switch timing should be less because whenever there is swapping happening, it might cause a time delay. So to reduce the time delay, we'll be using two system calls in your swapping mechanism. One is your request memory and another thing is your release memory. So using these two, we can reduce our context switch timing in the entire swapping mechanism. This will in turn reduce our context switching timing and your double buffering problem. So by reducing these two, we can have an effective swapping mechanism inside your system. One of the major drawbacks of swapping is swapping cannot be used in your mobile system. So in none of your mobile system, your swapping are not supported. So what will happen is, your mobile systems are flash memory based. That is the one main reason why you can't have a swapping on your mobile system. So take your Android and your iOS. So what will happen is, in iOS, the apps can voluntarily relinquish to allocated memory. So when there is a memory problem or whenever there is an allocation problem, either of your system, either it is an Android or your iOS, they can end up in process termination. So either you will be restarting the system or the particular app or a program will automatically be terminated. So swapping is not possible on your mobile system. It is possible only on your desktop or your other computer systems. So this is the one major drawback of your swapping. So to summarize, swapping is nothing but your exchange of your process between your main memory and your secondary memory. So this is the entire concept of